lined up, and
this is a heavy. I might have to skip out before the end because I'm supposed to be somewhere at 9, but it's only down the street. But you've got like a lot of stuff on the agenda.
yeah, it depends on what you want to see, right? Like, so Idit will start with Project Unik, and we're gonna get. No, we're not in here. It is open. You better be careful what you're saying.
I just realised that it's like a whole like.
Oh yeah, people are gonna start joining.
I take back what I said about Trump. He's great.
You don't have to do that.
Hey, if Trump could do one thing right, let you through, I can't argue with that one. He does a lot of wrong things already. So.
He's growing on me. He's done a lot about those lines. He said he'd bring back, he'd make America great again. Those lines are great.
We got Chip in there, tons of people. Roger. So I have 8 a.m. So we usually give people a couple more minutes for people that are trying to join right this minute, and then we'll get started. So they're not doing this meeting in here.
It's like it's off-site, but it's like just down the street. And it's supposed to be somewhere way more exciting, but then they changed it.
Yeah, I guess it is more exciting because Yui can't make it here, so she might call.
I think you probably concentrate there, but I'm like, you know.
Right. No, it's good.
I wouldn't miss a capital.
I appreciate it. I appreciate you being here.
Plus free coffee.
Yeah, we got Wayne here too. So that's good. Okay, so just a couple more minutes, we'll get started. Let's say 1 more minute. We have a packed agenda. So one quick thing.
Hey, Dr. Max, just making sure you can hear me okay.
Yes, indeed. Thank you, Chip.
Super.
So we're waiting. We'll start at 8:02 or so. I'm sending an email to Eric and Therese just to make sure they might actually be there. I just think. Yeah.
I'm here.
Ah, Eric, Therese, thank you.
Hi.
Hey, hi.
Hi, I'm Eric Johnson.
Oh, Eric. Okay, beautiful. So we have at least the speakers here, and then so that means we can get started at 8:02. And then we have Wayne. Yes, indeed. All right, thank you. So let me close the door, and then we'll get started. Are you coming? No. Okay.
Oh, so this is a closed door meeting.
It's open. It's actually funny. We are 2 IBMers at Pivotal.
It's a hostile takeover.
No, it's great. Pivotal is fantastic, as you know. They allow us to be here, so that's cool. Okay, so we have a packed agenda. It's really fantastic to have really 3 great talks, I think, by people that are trying to improve the community. So we're going to try to get to them as fast as possible. But as we usually do, we get a quick update from the foundation, and then maybe some highlights from projects, and then we'll just go straight to the presentations. Hey, Danny. Danny is part of the BOSH team, so I pair with him every now and then. With that said, maybe Chip, you can update us on the foundation. I want to mention the hackathon unless Tim Harris is there. So Chip, maybe you can give us an idea, like get us excited for Santa Clara.
Well, how about I actually talk really fast so that we can get to the interesting projects. Yeah, Santa Clara's coming, folks. June 13th. If you haven't registered, you should. Contributors, the code's been on the mailing list. Anybody that's sponsoring, you know, talk to your events team to get those codes, and otherwise just get yourself registered. We've got a little bit of news that we had opened up the Cloud Foundry Certified Developer program for a pool of beta candidates. That's all done. We know what the passing score is. So for those that participate in the beta, thank you. We'll be coming back to you with either a congratulations, you're now in the select few Cloud Foundry certified developers, or here's another code, give it another shot. So we're very thankful for their help through that process. And we've actually we had received about 300 applicants for the beta. So anybody that had applied for the beta that didn't make it into that group, you all have a code that should get you access to the exam at actually below our cost. So this will be really limited, and you have to get registered before Summit. Don't forget, we're also offering cert at Summit. There's really great training stuff going on the first day. So, if you're new to the community, or maybe something like Concourse sparks your interest, take a look at that. And yeah, then there's a hackathon, which I think is going to be amazing. We already have a good number of people registered for the hackathon. So maybe Dr. Max, do you want to just do quick view on that?
Yeah, take your Chip. So one of the things, so Tim Harris is helping run that. I'll be kind of emceeing part of it. But one of the things we're trying to do for the hackathon is to allow everybody to be part of it. So that means
it's not a hackathon if I'm not part of it.
Well, you can actually. So this is the cool part. The first day we'll have like a couple hours to introduce and kind of give people ideas of what we are looking for and so on. And then the hack starts. So that means if you go to a presentation and you're bored, you have your laptop, keep hacking, you know what I mean? So basically the hackathon is during the 2 days, and then we'll be selecting, so there'll be a date where you come and you say, okay, this is my hack. And then, so you can keep going to the conference, right? You just submit it. And then once we select, I think I don't want to know I don't want to say exactly is it top 5 or top 3, but anyways, we'll select a few that will get a chance to present during Abby's, keynote. So you'll get essentially visible time too. And then out of those presentations, we'll select the winners, and there'll be a significant prize.
How significant?
Robots.
I don't know. Go ahead, Chip. You know better than me.
Robots.
Okay, cool. To help you.
There's still a wide range that could be.
It could be a great robot. It could be a crappy robot.
Are we talking?
There's first, second, and third.
Like Transformers.
Just participate, man.
Well, there is first, second, and third place, man. So maybe first place will be a Transformer. We'll see.
Yeah. So basically, that means anybody can participate. We're not trying to tell you go to a presentation and not watch, but if you go there and you're bored, then hack, right? So that's the opportunity. Right. So that's the hackathon. One thing I want to remind everybody is that the call is being recorded. So watch your language. Not that I'm saying this, you Jules, but just everybody.
Everything I say is Queen's English, so it's by definition.
Yeah, you sound brilliant.
If I say it, it's not bad.
So for people who don't know, Jules runs many things in Cloud Foundry, including Garden or runC. He's the brain behind that.
Well, I'm one of the smaller brains behind that.
Cool. So that's for the hackathon. So definitely encourage everybody in your organization to participate. It should be fun, and hopefully something out of it will be interesting for the community. So that's it. Any questions about CFF or comments? No. Okay. So one more thing about the summit is that there is a summit for Europe that's coming, and it's gonna be in Basel, Switzerland. Really a nice city. I've been there actually this year, and it should be exciting. Swisscom is essentially helping run it with the foundation. So if you've never been to Switzerland, this is your chance to think about that. Cool. All right. So since there are no questions, I want to make sure we give enough time to the presenters. They're all here. So we'll go with each product in terms of like the core PMCs. If you have something to highlight, let me know. I don't know if Zach or anybody from the Runtime PMC wants to highlight something for you. Do you want to highlight anything?
I don't know. Well, so there's a couple of kind of cool things going on in Gardenland I'll highlight. So the first thing is we just started work to port Garden onto Windows. So this is sort of the next generation of the Garden Windows work. Before there was sort of this custom implementation with the Garden API on Windows that didn't really use containers. We're now moving the same Garden that we use on Linux over to Windows, and it's just going to use a Windows OCI binary instead of the runC binary used on Linux, but then share all the top level things, hopefully. So that's pretty cool. And if anyone saw the OCI buildpack proposal that we did at CF Summit, we're certainly not definitely going down the whole path of that because there's a whole lot of ocean to boil in that proposal.
Yeah.
But the Garden team has started doing the first couple of stories along that path. So we've started to exploit file system layers to improve performance of build packs. So instead of them just being used in the Docker flow, we're now trying to see where we can use some of that stuff. So instead of untarring droplets into the running container, we're going to pre-create file system layers and then create a container on top of them. So hopefully that cuts a lot of time out of the process. So if you've got a big JVM, we're maybe not going to have to keep untarring it and retarring it lots of times. So that the first couple of steps, first toe in the water down that line. But I think those are some pretty interesting things in Garden.
Yeah, very exciting. And I think the OCI buildpack proposal, there's still, the proposal is up for comments. So if you have comments, definitely make
sure. The proposal's up for comments, and the current state is we're kind of, there's about 7 or 8 kind of epic-like stories in that proposal. Okay. And we're just at the moment touching our foot in the water by doing the first couple and sort of get a feel for, get some of the early benefits, the low-hanging fruit, and then see how much we can motivate some of the later stories by seeing how much the benefit is and how hard it is. Okay. But we're very welcoming of feedback of people saying, yeah, we'd love the other stories, or no, we don't care about the other stories. But mostly the first one.
Cool. Thank you, Jules. If you have questions, this is the time. Let me also ask if anybody else from Runtime wants to chime in with any highlights. So, okay. So maybe let me see if Dimitri, are you here? You must be on mute if you're here. I'll give the highlight for him if he's not. So I actually joined the BOSH team for the past 2 weeks, and plus Danny is here too. I'll mention 2 things that he's been focusing on. Dimitri has been getting the team to get the BOSH DNS version 2. So this is, if you don't know what that is, you may want to look into, I think Dimitri has a BOSH notes on this, but essentially it's going to allow us to remove Power DNS, and it also allows us to remove console as a consequence in Diego. So this is a broad set of work that should make it a little bit easier. So this team has been working hard on this. And then also, just to mention, Therese will mention the BBR. So BOSH is supporting the BBR. So that's another piece of work that's going on. So that's that. And then for extensions, I'll just say that, we have 3 presentations that essentially sort of helps show that some of the things that were in the pipeline. So if you have a question about that, let me know. We're trying to put some structure around extensions, but also make sure that we invite people. So that's a consequence of this meeting, right? So giving people a chance to present. So let me see if there's any questions. If there's none, you remember you're on mute automatically, so you might need to unmute. Okay, I don't see anybody chiming. So Idit is gonna talk about Unik. So Idit, take it.
Yeah, awesome. So I'm sharing the screen, okay?
Yeah, I'll let you know. Yes, we can see your screen.
Okay, perfect. So I'm going to do it very, very quick. This is like a 1-hour talk and I have 15. So I'm going to run. I don't know who of you already saw some of the presentation. So I'm going to jump real quick between them and hopefully convince you. Okay, so when you're running today Cloud Foundry, the blessed flavor, usually you're running it on Ubuntu. And we're doing a lot of effort to make the container very secure, but actually you're still having the problem, which is the operating system is not really secure. So if you're running on Ubuntu, you're basically running that on that kind of stack, right? Every time that you're running it. So if we're looking at the Ubuntu distro itself, or any Linux kernel for that sake, you will see that it's very, very complex. And because it's very, very complex, it's because it's trying to do quite a lot of stuff. And it's trying to manage the drivers and the memory management, and it's protect your processes and so on. And that makes a lot of sense when they actually started the Unix operating system. And that's the problem that they're trying to solve, is time sharing. Because back in the day, they built this huge mainframe. It was very expensive to run one application. Therefore, they needed all of it. They needed a way to share it automatically. But again, this is not what we're doing today. Today, we can actually spin up an instance, and it will be a unique for an application. There is a lot of unnecessary component on the Ubuntu, for instance, distro. Today, there's still the floppy driver running there. If you're running on the cloud, you still have the USB driver, which means a lot of component that really is not needed are still included in your operating system when you're running. Again, you're just trying to run your application in Cloud Foundry, but you're actually getting all these things behind the scene that you are not aware of, or maybe you are. But in terms of memory management, again, the purpose of the operating system is to protect. The idea is that if you have two processes, we need to make sure that you are not writing to the memory of my process. And also, if your process is doing something very bad to the host itself, it's not taking the host down, because then that means that you also took my process, right? So that's the main purpose. But again, when we're running today, we're basically running one process usually, and therefore, there is no really need to protect between the processes and between the user. And all this overhead creating us a lot of complexity and a lot of vulnerability, a context switch and multi-address space and so on. There's so much unnecessary management layer there, because we're only running one process right now. I mean, if I just described that the stack, it's very, 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 very big, that means that also there is a lot of surface of attack is huge. And if the surface of attack is huge, you can actually penetrate from a lot of things. The last big attack that was in the US, so I think it actually was all over the world, was that an open source project called Mirai. Actually, it's an open source, so the hacker kind of like created a community to take the internet down. And what happened there is that they basically went to all the Internet of Things devices, and those Internet of Things devices actually running the operating system, and therefore there was telnet there. So no one cared about the telnet, because that's not what basically, they secure the application itself, but never the operating system. And therefore what happened, they kind of like took over bots, basically created an army of bots and took the internet down. So that's something that could happen also if you're running Cloud Foundry and someone is penetrated to the Ubuntu itself, right? It doesn't matter how secure is the container itself or how awesome Cloud Foundry is. What is important is that people can penetrate. Okay, here I'm basically, again, it's a 1 hour talk, but basically I'm explaining how complicated the Linux operating system is, how many lines there is. And again, I will run with it because I don't think we have the time. So I describe a lot of inefficiency, very quick, but I did. So the real question is how we get there, and it's quite simple, right? It's evolution. We started all the way for the mainframe, and until today, what we basically running everywhere is the Linux kernel. Again, Linux can run everywhere, and it can run anything. And because it's a multi-process, it's a multi-purpose operating system, there is a lot of unnecessary data there. So for instance, I can actually take the last distro of Ubuntu, run it on Pentium 1, it's still going to work, right? I don't need to. Okay, so again, we make a decision that it's more important to us to support compatibility versus efficiency. In the last DockerCon, Solomon introduced us the notion of Linux Kit. So what is Linux Kit? I will give you a quick explanation of what it is, but the idea is that you're probably familiar with an operating system like Core OS or runC OS or Photon OS and so on and so on. And the purpose is that you take in the operating system, you're still using the Linux kernel, and you're putting but you kind of like cleaning up the destroy itself and putting only what you need in order to run a container. That's great, but you're getting it out of the box. So if you want the Core OS, you're getting it built. What Linux Kit is basically a way to build something like that, to build an operating system that will be purpose for what you need. By the way, a lot of the design actually that is taken from Unik. And basically what you're doing, you're building it in a container and creating the operating system. Is there any question? No, okay. Okay, so that's the Linux Kit. Unikernel has a very similar approach. It's kind of like the team in Cambridge who in charge of the Unikernel are the one who actually did Linux Kit. And the purpose is the same thing. It's basically the same today. Every time you're running an operating system, application, you're always running the kernel. And on top of the kernel, you're putting all the OS libraries, always, right? This is a given. And on top of it, you're putting an application. No matter how many applications, you're still running all this stuff on the operating system. So what Unikernel is doing, they said, what if we will take only the application and we basically will take only the part from the OS libraries and the kernel that needed to support this application. So for instance, if your application doesn't need network, you're not going to have the driver of the network or any library that's related to it. So it looks something like that, right? Only the black part is going to be kind of like packaged together with your application. It's kind of like wrapping your application. And that's it. That's basically a bootable image. Now, in order to make it even simpler, we make a design choice. The community make a design choice. And the design choice is that we're only going to support one process and one user. Because if you're doing that, not a lot of the complexity of context switching, of memory management, of protection ring are not relevant. So we can remove it. There is no need to do all the time permission check because the administrator is the only one who's running there, and so on. So now we can actually take something like Ubuntu distro that it's a minimum of 1 gig size and reduce it dramatically to something like megs or or even Ks. So that's the idea. How to make it, I'm not going to, again, we don't have time, but basically there is some packaging tool that using the linkage and know how to take what it's need, basically the compiler, and basically wrap it as images. And what we did, we basically reduce all of this, right? So basically the idea is right now that all this middle layer, which the operating system that you don't need it and so on, it's kind of like move aside. And that means that you have less code, fewer bugs, and easy to reason about. So it looks something like that, right? Basically, this is the stack that we had before, and right now, basically, you're running on hypervisor. You can run also in bare metal. It just does not really make sense because it's very small, so you don't want to actually take all the machine and put this application on it. But so you're using an hypervisor usually, and people will come and ask, so what if we will take the container and put it on bare metal? And this is a good question, but the problem with that approach is that the operating system, the Linux, was never intended to serve as multi-application servers. And therefore, they're not going to leverage something like the hardware isolation that's given from the hypervisor. We tend to do that from, get-go. So it will be less secure, right? So it's basically very simple. And that's the difference between running container to a VM, basically, right? It's much more secure because it's leveraging the CPU hardware isolation.
But aren't there things like Intel has clear containers which do use the hardware?
Exactly, right.
It's just, there's nothing fundamental about Linux or containers that says you can't use that CPU instruction, right? It's a CPU instruction.
You can, it just mean that you will need to rebuild all the operating system for that, right?
But it may be simpler than rebuilding all my applications as Unik kernels.
That's true. So it's all trade-off, right? The question is what is easier and what it may give you more benefit. And it's a good question to answer. I don't know this answer. I'm tending to think that unikernel will be a bit better, but time will tell, right? In terms of advantage, so no permission check. So you utilize 100% of the hardware for the actual application. Again, this is, for instance, we not work with Click Container and so on. Isolation, basically microservices is sharing a lot of stuff. You're sharing the memory, the file system. There is a lot of advantage with that, but there also, disadvantage, which is it's less, you're still sharing a lot, so it's less secure. In terms of size, so we're talking about the difference between 1 gig, minimum of 1 gig at size when you look in the regular operating system to case, right? Basically, the size of the application is the size of the unikernel. And the short time is the boot time is really quick. And that will be very interesting to something like serverless. Because if you're looking today, people are reusing container for basically creating a hot container for serverless. And the reason they do that is because it's taking time to boot. With unikernel, the boot time is much quicker, so we can leverage that. And the surface of attack is tiny, but it's also custom. And this is very important. If you manage to penetrate to one of them, you will not be able to manage to penetrate to the others, or at least not easily. And the last thing is that I really believe that unikernel is the right approach. And the reason also the right approach, it's a and and no or, because what we're trying to build right now is an immutable infrastructure, right? This is what we're pitching all the time. We want to build an immutable infrastructure. And that's a really immutable infrastructure. You cannot SSH to the machine. You cannot put some patch. It's actually a really immutable infrastructure. And that's what I feel that this is a fit for microservices architecture. Promote performance, but again, I'm not going to go into details. You can see this online. The performance are much better. This is an example of Cassandra running on unikernel 10 times better in terms of throughput.
Sorry, what was that compared to?
So there is a company called Claudius. What they did, they took Cassandra and they put it on unikernel, specifically on OSV. And they basically took the regular Cassandra running on a VM, and they took Cassandra, their own Cassandra running on unikernel, and they did this benchmark.
I was just wondering if it's comparing versus a VM or versus a container.
It's VM, but I don't think that it will be dramatic. We're talking about throughput, right? Here, so.
Well, I guess what I was saying was I know unikernels are faster than VMs. My question is, what's the overhead versus a container, which is just a process? Right? There's no virtualization at all.
But you still eventually need to
run on a VM.
Well, no. So you've got your host, right? Your bare metal host, right? And now you can do two things. You can either run containers, so there's no virtualization, right? Or you can run unikernels in some sort of hypervisor. And my question is, I know that unikernels are faster than using a whole VM, but how do they compare to a container, which is really the question here, because we don't run VMs, right? But they use.
You're not running VM. Most of the people.
In this proposal, what you're swapping out is not the VM, right? Because then you'd be in the BOSH layer, not the Cloud Foundry.
No, actually, I am swapping the VM. I am
swapping. Wait for that. But don't forget, Idit, you have about 4 minutes.
Yeah. So let's go fast. But I am. I will show you in a second. So anyway, the only thing what we did with Unik is basically create a Docker, kind of like a Docker command line for a unikernel. It's very, very simple to use, and I don't have time, so I will not show you demos. But it's basically you building it. It is a VM, and therefore you need to tell me where you want to run. Because we need to compile the drivers, and then basically we're running it for you. So when you're doing run, you're actually running it for you, okay? We're supporting all of this unikernel, all of this cloud provider, but you kind of like ping on a point, because basically I'm kind of like transferring them both. The unikernel, the unikernel is basically we'll transfer the container and the server itself, the VM. Okay, I don't have time to do a demo. I will talk 1 second real quick about the integration that we did. So we didn't do the right integration, mainly because of time. But the right integration should be on the Garden, right? Basically, all the purpose of Garden is the fact that it can support different container. I think that it can also support different Unik, like basically VMs per se. Now, one thing that is very important, you actually nailed that. So today, when you're running your infrastructure, first you need to somehow manage the VM, right? And that's done in the BOSH layer, right? So BOSH is basically managing your VM. And
or bare metal, right? Depending on the CPI.
Yes, fair enough. Okay, but you need to run something to put the container on top of it, and you need to manage that. And the other thing that you need to do, you need to basically have something like Cloud Foundry or Kubernetes or whatever to actually manage the container itself. That means that you have two different tools to manage the same the infrastructure, which is not the easiest way to do. With Unik kernel, the idea is that the application is the VM, and therefore basically you're spinning it all on demand. So basically in that point, when someone actually said, I want this application, we're spinning a VM. Which means that you're not managing them separately. You basically manage them as one entity with one, basically Cloud Foundry will be the one who's managing that. Does that make any sense?
Yeah, but I think, so one thing I want to do a time check. You have about 2 minutes left. Jules is definitely the person you want to talk to at the summit. You guys need to chat, but just want to make sure that we get a chance for you to finish, Idit.
Okay, yeah, so I mean, I can show you a demo. What I wanted to show you is also these things, because I feel this is kind of like started from Unik kernel, but right now it also makes sense to run it as with Cloud Foundry generally, is basically a debugger. So in the beginning, it was a debugger for Unik kernel, but now it's a debugger for microservices, period. And what we created is a project called Squash. And the idea with Squash is that you basically, today when you debug your microservice application, usually you're looking at log, you printing and looking at log. And the idea with this project is that we don't think that you should do that. What we do think is that you need to attach debugger, and kind of like we created a distributed debugger. So the idea is that Squash know how to integrate with all this platform like a magic. Okay, I mean, you can look at the code, but it's basically doing a lot of magic. And on the other side is basically you can plug in whatever debugger you want. So we're using right now GDB and DLV, but you can have your favorite. And because we're using the debuggers, you can actually attach it to, we're getting for free support for every ID that you want. And what you're basically doing is looking at the code, putting a breakpoint, deploying it of Cloud Foundry, and then you actually can debug it. The breakpoint is kind of like you see all the stack, of all the application, basically. So it's a microservices debugger, which I feel will be very, very useful.
Okay, thank you, Idit. Let's see if there's like one question, not from you, from anybody else, just to give a chance if somebody has a burning question.
Oh, well, I just wanted to say that also Unik is going to support Linux Kit, because in the end of the day, we don't care if it's Unik or an operating system. What we want to give is the developer the ability to build very easy their code inside the operating system. So we're also going to support Linux Kit.
Is there a project page? Is this on GitHub?
For Unik itself? So, I mean, what I wanted to show you is that it's actually a very, very popular project. You're talking about Unik, or you're talking about...
Both.
Okay, so we show you. So Squash, one sec. So Unik itself, it's actually a very, very popular project that it already exists on the GitHub. And as you see, people are storing it, people are watching it, the graph is going, like if you're looking at the traffic, people are cloning it, people are working it. It's actually a very, very popular project. So I would suggest you to look at it. And Squash itself, one second, is not an open source project until we'll open it. It will take me, but I will open it probably beginning of next week, but it will be open. So you will be able to go there, go to the package, go to the platform, for instance, look at Cloud Foundry, see the integration there and so on. Kubernetes, for instance, we use the CRI. We also doing some meshing there with the fact that we want you to be able to debug your microservice from the beginning. So we're basically using exact, we're basically deploying a file, we call it app, that basically is the process, and then when it's attached to the debugger, we switch the process. So basically we're using exact function.
Okay, thank you, Idit. So maybe Therese, if you want to start setting up. The one thing I will say is, I mean, first thing is thank you, Idit. A really great presentation. I really like. I mean, one of my goal, and you know, if you have feedback on this, let me know, is to question assumptions. You know, when you look at Cloud Foundry, it's great, but where are we making assumptions that we can question? And I think Idit is essentially doing that. And usually huge advancement for science in general has been that. I mean, if you look at Einstein, he questioned assumption about Newton and he made huge investment. I'm not comparing it to this, but you know, questioning assumption is extremely important. So thank you, Idit, for doing this. Okay, so Therese, you can take it now. You have 15 minutes. You have to share your screen.
I will. Here we go.
Excellent. Thank you. So I'll give you a 5-minute check and then a 1-minute check. So when you see me raising those little pink cards, that's what it is. Okay, we can see your screen. So go ahead, Therese, please.
Brilliant. Hi, thanks everybody. I'm a product manager at Pivotal. I'd like to talk to you about BOSH Backup and Restore. So it's backup and restore for BOSH deployments and for BOSH directors. And the way it works is that BOSH, the BBR, I'm going to call it BBR, defines a contract with release authors. The binary BBR orchestrates the backup, and the release authors implement backup and restore. So it's a new model for us of how backup and restore works, in that responsibility for writing and maintaining the script sits with the release author. So that means that the scripts are, the backup and restore functionality is tightly bound with the release, so it doesn't get out of sync. And then if need be, the release author can do things to make their release more backupable. So it sets out a contract with release authors to call specific scripts in a specific order. So it will call lock first, then it will call backup, and then it will call unlock. And the binary itself, BBR, will call the scripts and move the backup artifacts. So here is a sample deployment with a sample flow. So BBR sits on a jump box. The operator types BBR backup deployment. BBR will SSH into the deployment, identify what scripts are implemented on what job, and then it will call all of the scripts of a particular type across all of the jobs. So it will call pre-backup lock across all of the jobs before it calls backup, and then it will call backup across all of the jobs, and then it will call post-backup unlock. And then after that, the scripts are called, it will then transfer artifacts from the deployment back to the jump box. And then it's the operator's responsibility to manage those artifacts and also to do things like scheduling and encrypting artifacts and things like that. So I suppose the point of this is that the thing that we are doing, we are taking care of the very center of backup and restore. So we're not looking at moving artifacts around, managing artifacts, doing scheduling. You know, there's no UX beside the CLI. So here's an example of how it would look like to back up Cloud Foundry. So you call backup on the director and Cloud Foundry, and then it does, this is just a more specific version of that other diagram. So you can see that what we'll do first is we'll take down the Cloud Foundry API within the pre-backup lock script so that we don't mutate state during the backup. Then we will call backup of the BOSH, which will back up the Postgres and the blob store, UAA, CredHub, MySQL, and the blob store in Cloud Foundry. And then we will call unlock. And then after that, all the artifacts will get transferred from the deployments to the jump box. So it's a way to take consistent backups of a distributed system. So next up, we'd like to open source the framework. We want to work with release authors to increase adoption. So talking to them about how the contract works. So because obviously the scripts have to be part of a release in order for BBR to work against a release. We're looking at optimizations like calling all of the backup scripts in parallel, other improved communication orchestration, looking at providing BBR as a library or an API, and then looking at things like pluggable artifact destinations like S3, for example. So shall I give you a demo now?
Yes, you have 5 minutes, so you can use part of it for a demo if you want to do that. Yeah.
Sure. All right.
Of course, if you guys have questions, get ready. We'll try to have a couple minutes for questions too.
Hang on a sec. All right. It's going to take me.
Yeah, we still see your screen. So.
Yeah. No, I've completely lost. I'm stuck, actually. Now I'm really completely stuck. I don't know how to do.
Okay, but we can trust that it will work. I mean, if you want to just take questions, I thought maybe.
Sure, I'll take questions. Sorry.
Yeah, so any questions? I have one question, but let me see if the community has.
Have you accounted for whether the release takes care of the storage and can signal this fact to the BBR subsystem?
Yeah, so it could be that you're talking about like an external S3, for example?
No, for example, maybe it stores it in the other and you have no idea where it is, but it stored it and it's taking care of it, and BBR is just saying backup, restore.
Yeah, so you could, that works. So the backup script could perform the external backup and return success, and then on restore, it would know how to retrieve that data and put it back. That's not a problem. Are there more questions? I cannot figure out how to.
Yeah, don't worry about it. I mean, I know this. Various releases are essentially integrating support for this, so this is real. We know that.
You need to just restore a backup.
Yeah, we can backup restore your desktop. So one question for you, Therese, is as part of this flow, I imagine that there are. Do you imagine if I have 5 different releases, including the director, of course, and so on, that there'll be those backups are happening in parallel, and you will orchestrate, essentially getting a snapshot for the entire platform, or you see it as you backup restore each one independently, and they are sort of separated. So the director is separate from my release, and if I have other releases, everything is completely separated. It's one command for each, or is there like an orchestration for the whole thing?
So you can back up all the things at once. So you can, for example, back up Cloud Foundry and BOSH at the same time by going BBR backup CF comma director. It depends on how sensitive you are to downtime, because when you lock, when you call lock for Cloud Foundry, it takes down the Cloud Foundry API. So if you have a long period where you need, if you're very sensitive to engineers not being able to CF push, then you might not want to do that, but it's completely possible. And we will, but the other point is that we will be looking at optimizations to make backups absolutely as quick as possible. So, even things like disk snapshotting, so that the downtime is minimized.
Okay, good.
Is it like, are there no databases that would do like online backups? Like, could we not build in some sort of online backup to avoid an outage?
I'm sorry, say that again?
I was asking, like, does MySQL or Postgres support like online backup so that you could take the backup without taking down the API?
Yes, the issue is consistency. So in MySQL, you don't have to call lock. But if you want, for example, your service bindings for MySQL to be consistent with what's in CCDB, you have to lock the CF API while you're taking the MySQL backup.
I see. I guess what I'm heading at is like, it feels like the feature that's hiding here is I want to be able to back up a Cloud Foundry. Ideally, I want to back up a Cloud Foundry without taking it offline. It feels like one way of doing that is if Cloud Foundry was transactional and how it wrote to the database, then you wouldn't need to take an outage. You could just use the online backup.
That's true. Yeah, no, this is like the first step. And in the future, we'd like to move possibly to backing up, like exporting instead of backing up. So moving to like an event stream. But for now, this is where we are.
My impression is that what BBR does is gives the structure, and then as Therese said, it's then up to the release author to decide which portions of that structure to use. So it seems quite plausible that the teams working on the elements of Cloud Foundry that would be relevant might look at how they iterate what they store such that they use just the pieces of the BBR that they need.
That's exactly right.
Okay, thank you for this question, Logan and Jules. Thank you, Therese, for presenting. Appreciate that. Okay, so last but not least, first time joining us is Eric Johnson from Google, and he's going to be talking about Kubo, which is kind of an interesting project that marries BOSH and Kubernetes, therefore Cloud Foundry Kubernetes. Woohoo! So there's some fans here. Eric, take it away. You might want to share your screen. Okay? Yes.
Okay, let me see if I can do the screen thing.
Show us the Kubo.
Show the Kubo. I don't have a demo.
That's great. Fine. No problem. We know it works. Okay, so we can see your screen, Eric. Go ahead.
Okay, great. So first of all, I want to apologize that you have to listen to me. Alejandro couldn't make it today, so I'm just kind of filling in for him. But this is a joint project between Google and Pivotal. Constantine is also on the call. He's been one of the core engineers. He's the anchor on the project right now. So kind of diving right in. Consumers, right, they have a lot of choices out there right now for things like, say, functions, app-centric systems like with Cloud Foundry, container orchestrations like with Kubernetes, and then of course there's data services, and a lot of this stuff sits on top of infrastructure. And I'm assuming everybody here is very familiar with the concept of BOSH to manage your infrastructure. Does a great job, obviously, for a lot of different things out there, including Cloud Foundry. And so today, the project du jour is to talk about how we can do that with Kubernetes as well. So I think infrastructure challenges with Kubernetes. So if anybody has played or spent any time looking at Kubernetes, it solves a lot of problems in terms of managing applications. Does that a lot with Docker images. And it does orchestrations of those workloads. There's a lot of constructs in there if you played around with Kubernetes to get kind of up to speed with. In terms of being able to manage fault-tolerant applications within the Kubernetes cluster itself. But Kubernetes on its own doesn't really pay any attention to the infrastructure underneath it. So while you may have an application that can handle some fault tolerance because of Kubernetes, if you were to lose, say, a virtual machine running on your cloud provider, Kubernetes does not take care of that for you out of the box. So this is where we look at BOSH to kind of come in and solve some of these problems for us for Kubernetes. So one of the things I think that we're looking at doing as far as where we want to take the project is provide a little bit more high availability of the Kubernetes constructs, the masters, as well as the worker nodes. And then the etcd nodes that sit alongside that. Scaling is another area where we can help Kubernetes. So a lot of times today, I think if you're running Kubernetes, depending on the infrastructure provider, you provision a cluster, you define a certain set of nodes. If you want to scale beyond those nodes, you're kind of stuck So we can leverage the power of BOSH there as well to provide scaling of those. For those of you who are obviously very familiar with BOSH, it already takes care of things like health checks with the resurrector, so it can bring back nodes that fail. And then obviously upgrades as well. So BOSH is a great tool for being able to do rolling updates across your infrastructure. And so that's another area where we can, where Kubernetes will be able to benefit is through upgrades. So just sort of evolution, I think everybody's very familiar with Google's Borg, at least conceptually, how we run containers internally. That was some of the concepts there were led into BOSH. And then what we're doing now, obviously, with BOSH and Kubernetes, leading to Project Kubo. So we talked a little bit about this on the previous slide. So Kubo today, right, it's a BOSH, and the Kubo release will be a great way for installing Kubernetes, as well as managing the operation of the Kubernetes cluster. So like I was just saying, day one activities, right? So how do you install BOSH, or sorry, how do you install Kubernetes? There's obviously many ways out there that you can do that today. So BOSH would provide yet another way of installing Kubernetes. But I think that the most important part of this is obviously the day two activities. So you've got your cluster up and running. How do you manage the VMs? How do you scale? How do you do upgrades of Kubernetes? And then obviously adding capabilities for high availability and multi-AZs. When we originally started with the project with Pivotal, a lot of this was to make Kubernetes available to Cloud Foundry applications. So the evolution of the project, I think when we started this, was to obviously have a Kubernetes cluster that was managed by BOSH, but then sit kind of alongside of Cloud Foundry that's also managed by BOSH. And so as applications would be set up in Kubernetes, we would propagate that information over to the Cloud Foundry system. What we're looking at doing now as far as the proposal to get into Cloud Foundry Foundation is to kind of backpedal a little bit away from that coupling with Cloud Foundry and look at creating just a standalone BOSH release for Kubernetes. And then Pivotal will be continuing to make that available as a product through an on-demand service broker that will still work well with Cloud Foundry, but we'll be able to kind of have the best of both worlds there. So roadmap, I think it was just last week, the team here at Google was meeting with the rest of the team in New York, and we kind of talked about where we want to go with the project, including making it a little bit more open source friendly, where the Kubernetes community could become more involved in this, as well as the BOSH and Cloud Foundry ecosystem. So I think where we're going to start focusing a lot of our efforts as far as the BOSH release goes would be for Kubernetes parity. That would be upstream support. So the kind of the core part of the next phase of the project would be to make it easy for folks within the Kubernetes community that want to get started with this to not require, say, a Cloud Foundry installation to be sitting nearby. So we'll kind of decouple that and create a standalone BOSH release for Kubernetes and support things like persistent volumes and other things like that that we haven't really tackled yet. So we talk a little bit about that here in the slide: networking, persistence, adding high availability support, so multi-master configurations for Kubernetes, sitting behind infrastructure load balancing or separate load balancers. This is not something that Kubernetes has out of the box, but relies basically on the infrastructure configuration for Kubernetes in terms of how to provide that load balance capability for multi-masters. And we can do a lot of that with BOSH sitting with the infrastructure. We're also looking at where Kubernetes is headed in general, upstream. One of the places that they're investigating is moving towards more of a self-hosted model. So instead of having a separate etcd cluster on its own set of VMs, they're actually looking at how do you bootstrap the etcd capabilities inside of Kubernetes. And so Kubernetes itself becomes the management platform for the etcd cluster. And so what we can do moving forward with the BOSH release is to start aligning in that direction as well. And then, of course, we can rely on the fact that BOSH already supports multiple cloud providers. I'm slightly biased towards Google, but it's great for customers to be able to have a multi-IaaS story. So here's a high-level architecture diagram for the standalone open source version. This is where we're headed as far as the Cloud Foundry Foundation CF experiment. What we want to be able to do is obviously just have BOSH manage the Kubernetes cluster. And so the diagram shows, the etcd nodes, multiple masters, as well as a set of workers. The Kubo architecture with Cloud Foundry, this is sort of where the project sits today. So as services are brought up in Kubernetes, the team had worked on propagating that information over into Cloud Foundry as well. So they're using route sync and an API route register that feeds that information over into Cloud Foundry. And then through networking, Cloud Foundry or Kubernetes apps are surfaced through Cloud Foundry. So you're actually going through the Go router to be able to talk over to the Kubernetes cluster. So with this new kind of direction of the project, we'll have sort of the standalone BOSH release that will become an artifact for this product that Cloud Foundry and Pivotal will continue to develop with the on-demand service broker. So question, what does this mean to Cloud Foundry? Obviously, so Cloud Foundry is a great place for running a lot of apps. There are probably certain cases where you may have requirements for your applications where Cloud Foundry isn't necessarily a great fit. Kubernetes could be a solution for that. So I think what this does is that this allows users to be able to look at Kubernetes as a way of deploying some of their application workloads as well as on top of Cloud Foundry. And then through the work that Pivotal is going to continue doing, be able to make those apps available to each other through probably even the Open Service Broker API. Those are future forward-looking kind of places that we want to see the project go eventually. So the Pivotal and Google kind of partnership on this, Google's been working closely with Cloud Foundry ecosystem over the last year, I want to say, to build out capabilities for running Cloud Foundry on top of GCP, and have developed a good relationship with Pivotal along the way. And this is just sort of a natural extension of where we were going with the work. And I think it's great for users to be able to access both Kubernetes and Cloud Foundry through the infrastructure tool of choice, which would be BOSH. So we're really excited about the opportunity to work with Pivotal on this and bring a little bit of that magic over into the Kubernetes community too. I think they'll be appreciative of BOSH as they get more exposure to this. I think that's the last slide. So
Okay, perfect.
Happy to take questions.
Yeah, excellent. Thank you, Eric, for a good overview. So we have about 3 minutes for questions. Anybody?
Yeah, I was wondering what the function or what the role of Power DNS is in the current setup.
Can you repeat the question? The role of what?
Power DNS. Oh, yeah.
Oh, Power DNS. Yeah, so we're actually looking at using the new BOSH DNS capabilities that was talked about actually earlier in this. So we're not using a vanilla BOSH director currently. We are looking at sort of where the direction of BOSH director is going with things like Cred Hub and pulling in the DNS capabilities into that. So those would probably be things that we'll continue to leverage and not rely so much just on Power DNS.
Okay. Thanks.
Cool. Any other questions? No, nobody? Okay, well, thank you very much, Eric, and everybody for joining. Of course, next month we have the summit, so see you all there. Take care. Thanks, Eric, Therese, and cheers.
Thank you.
Yeah. And this may